Book 2058. Why is Venus hotter than Mercury when Mercury is closer to the Sun? Why is Venus hotter than Mercury when Mercury is closer to the Sun?
Why is Venus the hottest planet, whereas Mercury is closer to the Sun?
Sejal M, age 7, Bangalore, India. When the solar system had just formed 4.5 billion years ago, Venus was probably a tropical paradise. Oceans of water likely covered its surface, and puffy clouds dotted its skies. At that time, Mercury, the planet closest to the Sun, was undoubtedly the hottest planet in the solar system. But then the Sun grew brighter, and a series of events known as a runaway greenhouse effect caused Venus's surface temperature to soar well past Mercury's. To be sure, as the closest planet to the Sun, parts of Mercury are still extremely hot. Its surface temperature on its sunlit side is around 800 degrees Fahrenheit, 430 degrees Celsius, hot enough to melt lead. I'm a space scientist with a passion for teaching physics and astronomy. I've seen Venus shine brightly in the western sky just after sunset, and on rare occasions seen Mercury briefly appear as an evening star. What is the greenhouse effect? Venus isn't the only planet that has experienced a greenhouse effect. Today, the same phenomenon keeps Earth's surface habitable. The greenhouse effect traps heat in a planet's atmosphere. Warm objects emit electromagnetic radiation, or light, because their atoms and molecules are constantly vibrating. Earth's surface is warmed by the sun and gives off infrared light, which is invisible to your eyes. Humans and animals also glow in infrared, and most of the energy released by a campfire is infrared radiation. The hotter an object is, the more infrared radiation it emits. On a planet without an atmosphere, such as Mercury, this energy escapes directly into space. As a result, there is an enormous difference in temperature between Mercury's blistering hot sunlit side and its night side, where temperatures can drop to minus 290 degrees. F minus 180 degrees C. On Earth, greenhouse gases in the atmosphere, including molecules of carbon dioxide, methane, and water vapor, absorb and trap some of this infrared radiation, acting like a blanket around the planet and keeping the surface warm. Earth's average surface temperature is about 59 F 15 C. Without greenhouse gases, the temperature would be closer to 0 F minus 18 C, and Earth would resemble a giant snowball. We definitely need a moderate greenhouse effect to make our planet habitable. Diverging fates, but how could Venus, a planet that is nearly the same size as Earth, and that was once made up of the same things, end up so different from our home world? There are several clues to why Venus is such a hot, unpleasant planet today. Scientists agree that because of their similar sizes and proximity to the Sun, Earth and Venus likely started out with comparable amounts of water and carbon dioxide. On Earth, most of the carbon dioxide is dissolved in the oceans or locked away in rocks, such as limestone. Venus may once have stored carbon dioxide in a similar way. Scientific models of stars indicate that the Sun has grown about 40% brighter since the early history of the solar system. 4 billion years ago, it emitted only about 70% of the energy it does today. Scientists disagree about whether Venus ever had long-lived oceans, but evidence suggests the planet possessed lots of water early in its history. As the sun's brightness increased, more and more water would have evaporated into the atmosphere. Without surface water to absorb and store carbon dioxide, nearly all of this greenhouse gas accumulated in the atmosphere. This process, in turn, would have caused even more evaporation and even more warming, a feedback loop known as a runaway greenhouse effect. Today, carbon dioxide makes up about 96% of Venus's atmosphere, and its surface temperature is a nearly constant 867 F 464 C day or night. Venus is now stuck in this state, and its atmosphere and surface temperature will remain like this for a very long time. Ancient Venus may have looked relatively similar to Earth, according to a NASA climate model. Imagine how thick Earth's atmosphere would be if all the oceans evaporated and all the carbon dioxide dissolved in them were released into the air. Something very much like this happened on Venus. As a result, the atmospheric pressure at Venus's surface is more than 90 times greater than Earth's atmospheric pressure at sea level. To experience such a high pressure on Earth, you would have to dive to a depth of about 3,000 feet, 940 meters. That much pressure is like having 5 elephants standing on your shoulders. A runaway greenhouse effect on Earth. You may have heard scientists warn that Earth could experience some of the same processes affecting Venus if human-caused climate change continues unchecked. Global temperatures are rising as people burn coal, oil, and natural gas for industrial activities and transportation, releasing large amounts of carbon dioxide into the atmosphere. Carbon dioxide stays in the atmosphere for a long time. As more and more accumulates there, it traps more heat, raising the temperature on the planet's surface. Another major greenhouse gas is methane. As Earth warms, an important source of methane is thawing permafrost, the permanently frozen ground found mostly in the Arctic. When the icy ground thaws, it exposes organic matter that had been frozen for thousands of years, including ancient plants, mosses, and even the remains of woolly mammoths and other large animals. Bacteria can then decompose that matter, and as they do, they release methane into the atmosphere. As Earth warms, more permafrost melts, releasing even more methane and creating a vicious cycle. Earth may never reach the extreme temperatures found on Venus today. However, our planet could become a much less comfortable place as temperatures rise. However, Earth's surface temperature will never reach anywhere near that of Venus in our lifetime, and Venus will remain the hottest planet in the solar system, despite being farther from the sun than Mercury. Hello, curious kids! Do you have a question you'd like an expert to answer? Ask an adult to send your question to Curious Kids Us at theconversation.com. Please tell us your name, age, and the city where you live. And since curiosity has no age limit, adults, let us know what you're wondering too. We won't be able to answer every question, but we will do our best.